Hello everyone, I'm Priyanka Rao, PhD student of 37th cycle in PhD program Health, Safety and Green Systems. The topic of my presentation today is enhancing green, regional to local scale resilient urban greening through remote sensing and geospatial analysis. We all have witnessed increasing temperature in last few years. Urbanization is posing a challenge on sustainable urban development due to complex relation between landscape and climate dynamics. There are several studies going on to understand this mechanism. In addition, regional disparities in urban green planning still exist for optimal thresholds of required green spaces. Based on these backgrounds, we have formulated following objectives: exploring the spatiotemporal nexus of land use type and surface temperature, identifying environmental stress hotspots, identifying the green and blue percentage thresholds at neighborhood scale, and analyzing cooling led by urban greenery at various geographical locations. Firstly, the remote sense satellite time series data has been collected and it has been processed using geospatial cloud platforms and Python and JavaScript libraries. The process data has been used to investigate the spatiotemporal trends and also to design the robust stress hotspot identification framework. Further, the process data has been also used to super resolve the surface temperature, which has been used to analyze the cooling effects of urban vegetation in various geographical locations and local scale assessment of green and blue area percentages. The results show that over the last decade, consistent higher temperatures has been witnessed with the significant changes in the land use. Built-up has shown the highest relevance to temperature change. Emilia-Romagna, with its temperate non-dry climate type, has seen a higher temperature anomaly rise from 2003 to 2023 compared to another region's temperate dry climate type. The pairwise comparison of multiple environmental parameters has been done to reveal the trend of air quality and heat variation alongside vegetation changes at regional scale. Further, local level identification of green and blue percentages facilitates the analysis of requisite threshold of land use types necessary for resilient development. So, the land cover alterations notably influence the land surface temperature. There has been a significant lengthening of the summer period seen. The design risk assessment framework facilitates the identification of the environmentally vulnerable areas to integrate cooling land use types into urban planning. The analysis of urban greenery contributions to cooling across various geographical locations shall elucidate that its influence on the cooling mechanism. Urban green infrastructure coupled with water management strategies yields synergistic benefits. For example, bioswales and rain gardens not only restricts and purifies the stormwater runoff, but also helps in mitigating the pollution and recharging the groundwater. And these two are being the part of the green infrastructure does that. In addition, the green roofs not only mitigates the UHI effect, but also restores the groundwater. Therefore, it further enhances the water resilience and sustainable green urban developments. There's a call out saying, for healthy and sustainable urban living tomorrow, start planning blue and green today. We would like to acknowledge the funding agencies of the research. Thank you so much.